Hello viewers, welcome to another video with your very own POC Guru. In this video, we are going to create a Kafka consumer using the Spring framework. Quick background about Kafka. Apache Kafka is an open source distributed event streaming platform for high performance data pipeline, streaming analytics, data integration and mission critical applications. For this video, I am going to bring up Kafka and Zookeeper in a Dockerized environment. If you already have a Kafka cluster available, you can skip the first part of this video. To run Kafka in a containerized environment, we need to have Docker desktop running. Check if Docker is running by opening the terminal and typing the command docker space ps. Kafka requires Zookeeper to keep track of all the brokers. So we are going to write a Docker compose file to bring up both Zookeeper and the Kafka brokers. Open a file and rename the file as docker compose.yaml. In the docker compose YAML file, start with the version and set it to 3. Add services tag and add the Zookeeper tag to it. Add the image confluent inc cp Zookeeper 7.3.0. This tells us that we are going to use the cp Zookeeper image with the version 7.3.0. Set the container name as Zookeeper and add environment variables of Zookeeper client port with 2181 and Zookeeper tick time as 2000. In the next line, add the broker service with the image confluent inc /cp Kafka :7.3.0. This indicates that we are using the cp Kafka image with the version 7.3.0. Give the container a name with the tag container name broker. Add the ports tag which maps the host machine's port to the port of the container. As Kafka runs on 9092 port, this will be mapped to the host machine's port. To make Kafka wait till the Zookeeper container starts up, we can add the depends on tag and add Zookeeper to it. Add environment variables to the Kafka container. The first environment variable is the Kafka broker ID, which is set to 1. The second environment variable is the Kafka Zookeeper connect, which is mapped to Zookeeper port 2181. The third environment variable is the Kafka listener security protocol map, where we map a plain text to plain text and plain text internal to plain text. The next environment variable is the Kafka advertised listeners, where we map a plain text to localhost 9092 and a plain text internal to broker 29092. The next environment variable is the Kafka offsets topic replication factor set to 1. The next environment variable is the Kafka transaction state log min ISR value, which is set to 1. The last environment variable to set is the Kafka transaction state log replication factor, and we set this to 1. Now that we have all these variables ready, save the file. Go back to the terminal and verify that the file is available. Use the docker compose up command to verify that the containers are up and running. You should be able to see the logs from Kafka and verify that the broker is up and running. Use Ctrl-G to shut down the containers and start them in a detached mode by using docker compose up space -d command. Now that we know that Kafka and Zookeeper are running in a containerized environment, let's jump to intelliJ and write our Kafka consumer. I have created a simple maven project, and as a first step, I'm going to remove the default packages created by intelliJ. I'm going to create my own meaningful package structure. So I'm going to create a package like com POC Guru Spring Kafka. I'm going to add an entry point main function by creating an app class. Let's add some springboot dependencies and spring Kafka dependencies to the pom.xml file. Let's add the parent tag in the pom.xml file to pull in the springboot dependencies. Add the dependencies tag and include the Spring Boot starter and the Spring Kafka dependencies. Refresh the project by clicking on the maven refresh button. Let's now start writing some code. Let's go to the app class and add the Spring Boot annotation on the top of the class. In the main method, add spring application.run app.class, args to start the Spring Boot application. The next step would be to create a Kafka config and write a Kafka consumer. Create a new package called config and add a Kafka Consumer config configuration file. In the configuration file, first add the enable Kafka annotation and the configuration annotation. Create the Kafka Consumer factory bean in the configuration file. The different consumer factory parameters that we use is the bootstrap server config, which has the Kafka broker and the port. We set the group ID config as group 1, the key deserializer class config as string deserializer, and the value deserializer class config as the string deserializer. As we are only working with strings for our Kafka messages, we can use the string deserializer. If you are working with custom objects, you can write your custom deserializer and provide the value here in the configuration. Add another bean, which is the concurrent Kafka listener container factory. This will create a thread-safe environment for our consumers. In the concurrent Kafka listener container factory, set the consumer factory that we created previously. Now that we have the configuration ready, let's create the consumer. Create a new consumer package. Add a new Kafka consumer class to it and annotate it with @service. Create a public void listener method that accepts a string as a parameter. As we are not doing anything with the Kafka message, we can just print it to the console by using the system out println statement. Add the annotation of the Kafka listener to this method. When we receive a message from Kafka, this method is going to get invoked. Add the topics that you want this Kafka consumer to listen to. As the Kafka consumers belong to a consumer group, provide the group ID. To make this Kafka consumer run in a thread-safe environment, provide the container factory as the Kafka listener container factory. We are almost done. Let's start the application. We can see that the Spring Boot application is up and running and the Kafka consumer is listening for messages on topic 1. Let's go back to the terminal. Let's verify that the Kafka container is still running by executing the command docker ps. Send a message to the topic on the Kafka container by executing the command docker space exec space it broker Kafka console producer bootstrap server broker 9092 and provide the topic as topic 1. Let's send a message to our Kafka topic. Hello from POC Guru. This is a Kafka Spring Boot demo for Kafka Consumer. Press enter. Let's open intelliJ and we should find the message as an output in the console. We can see that the Kafka consumer successfully consumed the message that was sent from the terminal to the Kafka broker in the containerized environment. That's it, POC viewers. Kafka consumer with Spring Boot under 9 minutes. Like, share and subscribe.